The historical inspiration for this sword was from a Kriegsmesser artifact from the 1500s. The final blade is a scaled-down version of that artifact and is made using the historical method of cutting and folding to clean the impurities from the steel before it is carburized. The metal for the sword was sourced from a wagon wheel from the 19th to 20th centuries and was not high quality even for the time. Because of this, significant effort had to be put in to create usable material, and in the end, had to be layered with modern steel in order to salvage the mechanical properties. This is a process not unlike the historical method of layering high carbon and low carbon steels to create a durable but hard final material, and can be seen in the etched layers of the blade. The metal started its life as a wagon wheel, and our processing began with hot rolling it into manageable pieces, both to prepare the microstructure for future forging and to make sure the pieces had a uniform width. Once they were flattened, they were cut into pieces roughly the same width the final billet was supposed to be, and were sanded to remove as much oxide as possible before they were consolidated into 9 billets and welded together. They were then forge welded together using borax as a flexing agent and cooled before being wrapped in steel foil for the process of hot rolling and recombining to begin again. This step was repeated to attempt to remove more of the impurities from the original manufacturing of the metal through the mechanical and chemical process of forging with a flexing agent. After the second round of rolling was complete, the process of carburization began. Carburization presented its own set of challenges. All testing that we performed on samples before putting the real metal in returned poor results. All normal methods of carburization we tried ended up reducing the total amount of carbon in the metal. We ended up using our last resort, 1000 degrees Celsius for 100 hours, and ended up at 0.53% carbon, less than our 0.6% minimum. Because of this, we elected to add layers of 1095 to improve the hardenability and structural integrity of the final blade. Once the material was carburized and layered with 1095 in 2 billets, each billet was folded in half once before they were combined and folded one last time. The billet was then drawn out to the final length of the blade. Once it was long enough, the rough shape was put into the blade to prepare for heat treatment. The blade was heat treated using the MFA site's large furnace. It was wrapped in steel foil and normalized twice at 830 degrees Celsius for 20 minutes and cooled for 40 minutes afterwards. It was then heated once at 830 degrees for 15 minutes unwrapped before being removed and weighed down to try and make the blade more level. It was then reheated to 1030 degrees Celsius for 12 minutes before the final quench, which was done using canola oil. The blade was then tempered and straightened the final time before it was sanded and etched with dilute sulfuric acid. Final assembly was completed using a 2-part epoxy to hold the pieces in place. During all parts of forging, sanding, and etching, safety glasses were worn, along with cotton clothes and leather shoes. Additional safety equipment was used depending on the task being performed and can be seen in this video. Some additional pieces of PPE include leather gloves, face shields, and silvers used during particularly volatile hot work.